In order to confine the ITER plasma, we need to manufacture gigantic, disc-shaped superconducting magnets, the toroidal field coil. I'm standing here in front of the 1D pack, which is the core of the TF coil. The dimensions of the TF coils are quite large. They are 16 meters long, 9 meters wide, and they weigh 300 tons, the weight of a Boeing 747. In the ITER machine, there will be installed 18 TF coils. 10 of them are produced in Europe, and Japan is producing 8 plus 1 spare coil. The TF coils are among the biggest and most challenging superconducting magnets ever produced in the history of mankind. "750 meters of conductor are bent into a double spiral trajectory to form a double pancake. The length of the conductor during winding needs to be controlled with an accuracy of 0.05 millimeter per meter. The conductor is formed by a cable of roughly 1,400 superconducting niobium tin and copper strand fitted inside a stainless steel conduit of about 45 millimeter in diameter.
To make the double pancake superconductive, it needs to be heat treated at 650 degrees Celsius in an inert atmosphere. The conductor of the double pancake must be fitted inside the radial plate, a stainless steel structure with grooves on both sides. In order to fit the conductor inside the grooves of the radial plate, their trajectory must match perfectly. This task is performed by the insertion tooling. The conductor of the double pancake is then wrapped and electrically insulated using several layers of glass fiber and capped-on tape.
The double pancake conductor is then locked inside the radial plate groove by the cover plates, which are subsequently laser welded by 3 robots working simultaneously. The total length to be welded is around 1.5 kilometers.
The double pancake must then be wrapped with an insulating material. Next, it is transferred to a mold to be impregnated with resin. This is cured at high temperature, removed from the mold, and goes through a series of final checks. The manufacture of a double pancake is then complete.
Then the 7 double pancakes are stacked, electrically jointed, wrapped, and finally electrically insulated with glass capped-on tape to form the winding pack.
In the impregnation mold, the winding pack is wrapped in between stainless steel sheets, compacted and welded together so that we have a closed volume. In this closed volume then, we suck vacuum in order to eliminate all the remaining humidity and gas trapped inside the insulation. After that, the resin is slowly injected so that we soak the whole assembly, and after that we increase the temperature up to 155 degrees and leave it there for several days so that the resin becomes hard and the electrical insulation becomes solid. After then the cool down cycle, we peel off the casing and obtain an impregnated winding pack.
Before delivery, a series of final tests are carried out, including dimensional checks using laser scans, in order to ensure that the completed winding pack is compliant with technical requirements.
And last but not least, temperature sensor, voltage tapes, and helium pipes are assembled to complete the winding pack. The magnet is assembled in a large and heavy transportation steel frame to be shipped to another facility. It will have to travel from the port of La Spezia to the port of Marghera, which is located to the opposite side of Italy. In this facility, the winding pack will be cold tested and finally inserted in a stainless steel coil structure. This impressive superconducting magnet, unique in its kind and dimension, is the result of 10 years collaboration between Fusion for Energy and more than 26 companies involving more than 600 people across Europe.